Hi, welcome to part 3 of the chucK granulator tutorial. So last we left off, we created a single grain in chucK. Where did we go here? Right? And we've repeated it a couple times there. So what we're going to do this time is we're going to create a function and put our single grain into a function. And we're going to move some things outside of the function as well. So let's get started with that. We're going to move this business, the sound buffer and the buffer outside of the function. So let's copy that and paste that in there. Okay. And then we're going to change the name right now to buff1, and you'll see in a minute why we do that, and buff1. Okay, and then if you want to go check out the function, just go to this address in the chucK language, and you'll get, oops, so I had it. Oh, here, it must be here. Yeah, functions here. Okay, so that kind of explains a function, but it's just very similar to functions in other languages. Though in chucK, they can act a little bit like, kind of like classes, kind of a mixed in between. But we'll get into that in a bit. So let's start our function right now. Fun. It's not returning anything, so we're going to say void. Sorry, let me get the proper code up here so you can see it as well. We're going to declare our function here. We're going to call our function, give it the name grain. Okay, and we're going to have a bunch of arguments eventually, and we'll get to that. But they go in the parentheses. Okay, and that's our function there. All right. Now, let's grab all this code here from our single grain. Remember, we externalize these ones. We're going to grab this stuff and paste that in there. Okay. So once again, our function's going to do the exact same thing. Create our patch, gain G to the DAC. We're going to add a buffer to G, and then we're going to have an envelope buffer to G. We're going to multiply them, and then we're going to have the position here, the rate of the actual sound file, the source, and then our envelope position is always going to be 0, and then we're going to have a grain duration in there as well. Okay, and then this calculates the length of number of samples, or the rate, actually the frequency, to make it that duration, and then this moves it forward in time, right? Just a quick review there. So let's start adding some arguments there. So buffer here, we changed this to buff1 because we want this to be an internal to the function. So we're going to create an argument there, sound buff and buff. And then we're going to create another sound buff, and we're going to make it buff. Okay. And then we're going to multiply it, and then we have a position here. So we're going to have another argument called post. So we can have a random position. We can change the position per grain. That's a position you're reading from, the sample you're reading from in the audio buffer. Okay. Going to be int. Okay. And then, I'm sorry, this is going to be a float, isn't it? Oh, no, I guess position is integer. Oh, it's a sample, right? So it should be integer, right? Because it's the sample number. You don't need a float for that. And then the rate here, so it's 1 here, but we can change the rate per grain again, and that's kind of the speed of playback of the actual individual grain. So let's put rate there, and that one could be a float. And then the grain dior, I guess we're getting rid of this because oh, it's just in here. So we're gonna make it a argument here in milliseconds. Okay, so this is going to be the grain dior there, and then we're going to advance time that far ahead. So then now we have our grain as a function. So we can call this individual grain several times as a function, and chucK has a way to do it concurrently. So we can create a bunch of grains at the same time and create like a granular cloud. Okay, and the way we do this is the sporking. This kind of terminology is unique to chucK, but it's very much like, kind of almost like instantiating a class, even though it's in this function format. It's just a quick way of instantiating that function and run them concurrently. So if you spork a function, you can run a bunch of them, and you'll see that we're going to do that later on, a whole bunch at the same time. Okay, you can look at the file there if you want. All right, so let's go ahead and do that. We'll spork it, tilde, and then we're going to spork the function grain. And then we're going to have our arguments there. So the sound buffer is going to be buff1. The envelope buffer is going to be buff1. And then our position will start at 0 for that grain, And then the rate, we can be 1. And then the duration, we'll say 700. Okay. And there you go. That's our grain. And the parent now, even though we're moving ahead time per grain, we still have to move ahead time for the parent. So we go 1 day and chucK it now. All right. And there we go. That should be our grain right there. And there you go, 1 grain. Okay. Now the next step now would be to just repeat the grain. We're going to do something similar to what we had before really, but just get things set up for the next step. So let's go ahead and move some variables around. Now the function will read, just like when you compile, it'll read before it reads anything else. It'll just store that function, right? So we can just pop that down somewhere here with all our other functions if we write any other functions, okay? And we're gonna do a couple things. We're just gonna create the variables outside. So we're gonna create a grain dior, and then we're gonna create a gap between each grain, a duration for the gap. Okay, and then we'll declare our sound buffers out here. Let's say sound buff 1, env buff 1. Okay. Now we're going to have a repeat here. And we're going to fill the buffers each time for every grain, each grain, right? So we're gonna read the sound file into the buffer and then spork a grain, all right? And we'll do that 30 times. So that's gonna be buff 1, env buff 1, 0 will be our position. We'll just leave that for now. I mean, you can have a position if you want. And then we'll have, this will be, the rate, and we'll just keep that at 1. And we'll have G dior there, all right? And then we'll have a grain gap here. So it's gonna play a grain. It's gonna spork the grain function there, play the grain, and then it's gonna wait a certain amount of time and then repeat, right? So we'll have the G gap. This will be how long it'll wait in milliseconds. And then move time forward like that, all right? And so it's gonna play the grain, load the sound files into the buffers, play the function, wait a little bit, and then repeat, okay? And then we're moving again time forward on the parent right here. All right, let's see how that works. Okay. All right, and there we go. We have multiple grains, and then we introduced another variable called grain gap. So this is all fine. However, we can only play 1 grain at a time. A lot of granular synthesis is going to involve overlapping grains. So you want to be able to play grains independently on their own shred and then have another grain take its place. We're going to have multiple, we're going to spork multiple grains at the same time, okay? So we're going to do a couple things here to get that working for us. So let's see, this is so I don't think I mentioned it yet, but this is where you can find the code for these tutorials. And we talked about sporking and stuff like that, okay? So to do multiple grains, we're going to have a couple things to help us have concurrent grains, all right? So we're going to have just a maximum number of concurrent grains that we want. I'm going to call it max gr, okay? And then now what we're going to do is, since for every grain we load its own buffer, right? And we have 2 of them, one for the source and one for the envelope, right? So we're reading those into those sound buffer objects. So what we're going to create now, in this case, we're going to create an array of sound buffer objects so we can read in multiple buffers into their own sound buff object and then play a grain for those. So each grain needs its own sound buff for the source and for the envelope. Okay, so we're going to have a sound buff array, and we'll call it buffs. And the length, you just have to declare the length, is going to be max grains, the maximum concurrent grains. And then another sound buff we call ends, and those as well are going to be max grains. Okay, and then we're gonna we're gonna keep this GDOR and GGAP right now, and we don't need these now because we have an array of those. All right, and now instead of repeat, we're just gonna do while true, an infinite loop. Okay, and that's just gonna keep going forever until we stop it. And then what we'll do is we'll do a for loop here so that we can instantiate multiple grains. So we're going to do for 0, oops, I is less than max. And this is a standard for loop, but you can look up in the chucK language as well. You can look up for loop and you can see how chucK handles it. Just slightly different in that you use this kind of variable, the chucK method of chucking things. Okay, and then let's do that. Read those, spork, green gap, and then end our for loop. Okay, and then end our while loop. All right, so this will keep this for loop going. It'll just run this for loop over and over again and just keep that. And so we need kind of a within that while. So this is going the frame rate or whatever the rate is as fast as possible. So what we'll do is we'll in the while loop, in the infinite loop, we'll have a kind of frame rate we'll create. So you have to be very explicit about time and check. So we'll just have say 15 milliseconds. That's plenty of time to do 100 grains. All right, so this will do this. It'll run this loop, wait 15 milliseconds, and then run that loop again, wait, then run this for loop again. All right, so a couple adjustments here. You can see over here, instead of just buff1 and envelope single ones, we're going to use our for loop in the I there, and we're going to go buffs I. So it's going to store, if this is the first one 0, it's going to store in buff 0 here, our sound file, and it's going to store envelope envs 0. Oops, sorry. If it happens to be 0, index, and then it'll spork these, and this will be again buffs I and envelopes I. Right? It'll spork that using those buffers that we just loaded, and then 0, 1, GDOR, right, and then we have our GGAP. Then it's going to wait that long for our gap, and then repeat 100 times. Okay, so now we can have overlapping grains. So let's have the grain gap be rather short, and let's have the grain duration be rather long, and then we get some nice overlapping grains there. Okay. All right, that's pretty annoying. Let's make that slightly bigger. Well, you don't really hear the overlap there. Okay, well, anyways, you can tell that the grains are overlapping there anyways. All right, and so that will do it for that tutorial. We now have a way to create overlapping grains, and we have a bunch of parameters which we'll look at in the next tutorial. So we have our duration, we have the gap, we have how many grains maximum we can overlap them. We have all our things in our function, such as position, rate, and then the gap duration, grain duration. So we'll take a look at those in different ways we can play with that. And that's really getting to the heart of granular synthesis now, is playing with some of these parameters. And essentially we have what we need to create green clouds. Okay, thanks very much.